Hello dear students, today we are going to start maxima and minima, okay? Second order derivative test. First is framing function or else given function is it's okay. Next, differentiate the function and make it equals to function equals to 0 to find critical points or extreme points, okay? To find critical points or extreme points. And double differentiate the function. Okay? Next, substitute the critical point. Let us say critical point is x1, okay, here. So substitute critical point in the double differentiation. If the result comes out to be positive, okay, that means f double dash of x is greater than 0, then this is said to be minima. It is said to be minima, okay, minima. It is said to be minima, and where it is minima? Where it is a minima? At x is equals to x1, it is a minima. What is a minimum value? What is a minimum value? Minimum value. F of x1 is a minimum value. Okay. So next, substitute the critical point in double differentiation. If it comes out to be negative, then this condition is said to be maxima. This is maxima. Okay. Point of same point where it is maxima, at x1 it is maxima. Okay. In similar way, double differentiation x substitute x1. So this is said to be a 0. Then this is neither maxima nor minima. Okay. Neither maxima nor minima. Okay, neither maxima nor minima. So here we have a question: find the maximum and minimum values if any of the following function given by. So first problem rules. Okay, given f of x is equals to 2x minus 1 whole square plus 3. So this is a function. Differentiate with respect to x. Differentiate with respect to x. So here f dash of x is equals to differentiation of x to the power of n. Here we have a differentiation of f of x whole to the power of n. Can be written as n into f of x whole to the power of n minus 1. Again differentiation of f of x. This is the formula. Okay, this is the formula. Here function is 2x minus 1. So differentiation of 2x minus 1 whole to the power of 2 is 2 into 2x minus 1 whole to the power of 2 minus 1. Again differentiation of inside function. Plus differentiation of constant is 0. Okay. So f dash of x is equals to 2 into 2x minus 1. Differentiation of x is 1. Okay. Differentiation of x is 1. So 1 minus differentiation of constant is 0. 0 is nothing but 0 only. I am not writing that. F dash of x is equals to 2 2s are 4. 4 times of 2x minus 1. Now let f dash of x is equals to 0 to find critical points. Okay, critical points. So here f dash of x is 4 times of x, 2x minus 1 equals to 0. 4 send it to the right hand side, it will become 0. 2x minus 1 is equals to 0. Send this 1 minus 1 to the right hand side, it will become plus 1. Okay, plus 1. Send this multiple 2, it will become divide. Okay, x is equals to 1 by 2. Therefore, this is 1 by 2. X is equals to 1 by 2. This is a critical point, we got it. But we don't know whether this is a point of maxima or point of minima, we don't know. So just plot on a number line. This is a first order derivative. So this is a 1 by 2. Okay, 1 by 2 we have. Now this is minus infinity, this is plus infinity. Consider any number. First of all, consider the slope. What we have slope. F dash of x is equals to 4 times of 2x minus 1. Okay. So slope just note down slope. 4 into 2x minus 1 is the slope. Now consider minus infinity to 1 by 2 any number. Okay, any number. That number substitute in the slope. Okay, this slope in the place of x. Minus infinity to 1 by 2, consider minus 1. So I'm considering minus 1. So I'm substituting in the place of x minus 1. So 4 times of this is minus 2 minus 1, which is minus 3 minus 3 4 is 12, minus 12. So negative you are getting result, right? That means less than 0, negative. So this is negative. I'm putting negative. Next, if I substitute 1 by 2 to infinity any value, let us consider 2. If I substitute 2, then f dash of 2 is equals to, substitute in the place of x2. Okay, 2 into 2 minus 1. So what is the result? 2 2s are 4. 4 minus 1, 3. Right? 4 minus 1, 3. 3 4s are 12. This is greater than 0. Positive. Hence, minus infinity plus minus infinity to 1 by 2, you are getting negative. 1 by 2 to positive. 1 by 2 to infinity, you are getting positive. So the slope is changing from minus to plus by crossing this. So what I said here, if a slope changes from minus to plus, then that is the point of, this point is x is equals to 1 by 2 is the point of minima. Hence therefore we can make a note of as this. So x is equals to 1 by 2 is point of minima. X is equals to 1 by 2 is point of minima because the slope changes from minus to plus. Okay, next, finding the minimum value. Minimum value can be found by using f of 1 by 2. Substitute 1 by 2 in function. Okay, in function. What we have function actually? Function is a given function here. 2x minus 1 whole square plus 3 is given. Okay, 2x minus 1 whole square plus 3 is given. So f of 1 by 2 is equals to 1 by 2 substitute in place of x. 2 cancel. 1 minus 1 0. 0 plus 3. So f of 1 by 2 is equals to 3. So minimum value we have 3. Okay, minimum value we have 3. And that's all. This is the minimum value. Minimum value is equals to 3. That's all. This is the solution. Is this clear? This is a procedure. For a function, differentiate the function, make it equals to 0 to find critical points. And we got a critical point, just plotted a number line and finding a sines of a slope. Changing slope from minus to positive. So therefore we can say this is what? This is what? Minima. Okay, this is minima. That's all. This is the solution. And we can solve, you guys can solve second, third, fourth, right? So consider as the remaining as homework. Okay. Second, third, fourth, consider as a homework problem. Here we have a question. Find the maximum and minimum value of any of the following functions given by. So here second problem. First bit. Given function f of x is equals to mod of x plus 2 minus 1. Here always modulus function is greater than or equals to 0. Okay, always modulus function is greater than or equals to 0. Now here the modulus function, inside the modulus function, here we know that modulus function is always greater than or equals to 0, right? Greater than or equals to 0. In the function we have minus 1, so subtract both sides by minus 1. Subtract both sides by minus 1. Subtract both sides by minus 1. So modulus of x plus 2 minus 1 greater than or equals to minus 1. Therefore, here what is given? This entire thing is function f of x, right? F of x greater than or equals to minus 1. Therefore, we can see here this is a minus 1 greater than or equals to either 1 or f of x greater than minus 1 means minus 1 or more than 1. Okay, comes into here. That means entire interval moves to up to infinity. So we can say minimum value is minus 1, right? But we can't say maximum value because that is approaching towards infinity. So this is we can say minimum value is minus 1. Hence therefore here minimum value is equals to minus 1. Okay, minimum value is minus 1 because it is approaching towards infinity. We can't say maximum value. So hence minimum value is minus 1. That's all. This is the solution for the first question. Next step. Second question, what is given? Well, write g of x is equals to second bit plus 3. G of x is equals to minus of mod x plus 1 plus 3. So here we always know that modulus function always greater than or equals to 0. Now multiply subtract or multiply minus sign both sides. Okay, multiply negative sign on both sides. So if I multiply negative sign, greater than or equals to will become less than or equals to 0. Okay, here why I am multiplying negative? Because in the function we have a negative. That is the reason why we are multiplying negative. So both sides add 3 on both sides. So minus of x plus 1 plus 3 less than 0 plus 3 is 3. So this is entire thing is function g of x, right? This is g of x less than or equals to 3. This means what here? This is 3 and less than 3 means the entire g of x is always less than, means here this value is approaching towards minus infinity, right? So we can say here when comparing to this, 3 is maximum value. We can't say minimum value is infinity, right? So hence we can say here maximum value is equals to 3. That's all. There is no minimum value for this function. Clear? That's all. This is the solution. This is the solution. Here we have a given function. Given function h of x is equals to sine of 2x plus 5. Okay, sine of 2x plus 5. Now we know that range of sine 2x always lies from minus 1 to plus 1. Okay, see carefully guys, sine theta always lies from minus 1 to plus 1, but sine square theta always lies from 0 to 1. Okay, 0 to 1. Make a note of it. Okay, now both we have in the function phi, right? Both sides add phi. Add phi on both sides. So both sides add minus 1 plus phi less than sine 2x plus phi less than 1 plus phi. So minus 1 plus phi is how much? 4 less than. This is sine 2x plus phi is what actually h of x, right? H of x is a function. 1 plus phi is 6. Therefore the function value, minimum value is 4. So minimum value is equals to 4, maximum value is equals to 6. Okay, that's all. This is the solution for the given question. Okay, given function here sine 2x range value lies from minus 1 to plus 1, hence adding both sides phi you are getting minimum value, maximum value. That's all. This is the solution. Here we have a fourth problem. We know that sine 4x lies from where to where? Minus 1 to plus 1, because range is minus 1 to plus 1. Okay. Now we have in the question 4x plus 1, 4x plus 3 whole modulus. Here add both 3 on both sides. Okay, add 3 on both sides. Add 3 on both sides. So minus 1 plus 3 less than or equals to sine 4x plus 3 less than or equals to 1 plus 3. Minus 1 plus 3 is 2 less than or equals to sine 4x plus 3 less than or equals to 1 plus 3 is 4. Okay. Now apply modulus on both sides. Modulus, 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 modulus. So hence this is 2 less than or equals to, this is what? F of x less than or equals to 4. Okay. So therefore minimum value is minimum value 2, maximum value is equals to 4. That's all. These are the solutions for the given question. Okay, that's all. And the third question is asking to find the local maxima, local minima. If any of the following function, find also local maximum value, local minimum value. Okay, so I will solve this second problem. Try to solve first problem, homework. Okay, first I will solve second problem, given function. Second problem, given f of x or g of x. Okay, fine. This is a g of x is equals to x cube minus 3x. So this is a given function. Now differentiate the function. First step is differentiate with respective x. So g dash of x is equals to differentiation of x cube minus 3 into differentiation of x. G dash of x is equals to differentiation of x cube is, we know, differentiation of x to the power of n formula, right? N into x to the power of n minus 1. So follow this formula. Okay. So 3 into x to the power of 3 minus 1. 3 into differentiation of x is 1. Okay. Next, g dash of x is equals to 3 into x square. 3 minus 1, 2. So this is square minus 3. Okay. Next, take common 3. Take common 3. So x square minus 1. Therefore, let g dash of x is equals to, make it equals to 0 to find critical points. To find critical points. Critical points. So from here, 3 times of x square minus 1 is equals to 0, and x square minus 1 equals to 0. A square minus b square formula. Okay. A square minus b square formula is a plus b into a minus b. Okay. So this is the formula. So here I am writing a plus b into a minus b equals to 0. Therefore either a is equals to 0 or b is equals to 0 in the same way. X plus 1 is equals to 0 or x minus 1 is equals to 0. Here x square minus 1 can be written as 1 square. So the formula follows here. I wrote here. Values are x is equals to minus 1 or x is equals to plus 1. We don't know these values. Whether this x is equals to minus 1 is a point of minima or point of maxima, we don't know. X is equals to 1 is with a point of maxima or point of minima, we don't know. In order to find this, now double differentiate. Make it equation 1 this. Okay, call it equation 1. First differentiation, g dash of x is equals to, call it equation 1. Now equation 1 implies g dash of x is equals to 3 times of x square minus 1. Now again differentiate this function. Okay, differentiate again. Differentiate with respective x. So it will become double differentiation, right? It will become double differentiation. So here we have function double differentiation, double dash x is equals to, again 3 into differentiation of x square, again differentiation of x square minus differentiation of constant, differentiation of constant. So 3 into differentiation of x square is 2x minus 2x minus 1 differentiation is 0. So 3 2s are 6 into x. So this is double differentiation. Okay. Now for substitute critical point. Okay, double differentiation at x is equals to minus 1, then what is the value? 6 into, in the place of x, minus 1 substitute. So what is this? Minus 6. Therefore double differentiation is less than 0. It is maxima. It is maxima condition, right? Where it is maxima? Where it is maxima? At x is equals to minus 1, it is maxima. It is maxima. And maximum value is g of minus 1 is the maximum value. Okay. Now next, x is equals to 1, substitute in double differentiation. Double differentiation, in the place of x is equals to 1, I am substituting 1. So here we have double differentiation, substitute in the place of x1. So it is positive, right? This is 6 greater than 0, and this is the minima. It is minima. It is a minima. So x is equals to 1 is a point of minima. Point of minima. So therefore we call it as hence we got a point of minima, hence we got a point of maxima. This is point of maxima, this is point of minima. And maximum value substitute in the place of g of x, in the function g of x, substitute minus 1. You will get it, you will get the max, substitute minus 1. You will get the maximum value. So here g of x is equals x cube minus 3x. So if I substitute x is equals to minus 1, if I substitute minus 1, then what you will get? X cube is what? Minus 1 whole cube. Minus 3 into minus 1. So therefore minus 1 cube is always minus 1. Minus into minus plus. So plus 3. Therefore this is 2. 2 is maximum value. Next, substitute in the place of x1. Okay. Substitute in the place of x1. Substitute in the place of x1. So 1 minus 3. So g of 1 is equals to 1 minus 3 is minus 2, which is minimum value. This is minimum value. This is maximum value. So hence, if I substitute minus 1 in the function, you will get 2 is a maximum value. And at 1, it is minimum value. Hence done. This is the minimum value. Minimum value. This is maximum value. That's all. This is the. Your third problem is homework, consider as. Okay. And remaining problem are homework all. Fourth problem I will solve. Okay. Given function f of x is equals to sin x minus cos x. Sin x minus cos x. X lies from where to where? 0 to 2 pi. Now first is differentiate with respect to x. Differentiate with respective x. So f dash of x is equals to differentiation of sin x minus differentiation of cos x. So differentiation of sin x is cos x. Cos x differentiation is minus sin x. So minus into minus plus cos x plus sin x. F dash of x is equals to cos x plus sin x. Here we know that the differentiation formula, differentiation of sin x is equals to cos x. Differentiation of cos x is equals to minus sin x. Okay. This is the formulas. So we substituted the formula here and we got it f dash of x. Next, let f dash of x is equals to make it equals to 0. Okay. Make it equals to 0. Then to find critical point. To find critical points. Critical points. So here cos x plus sin x equals to 0. Bring the sign to the right hand side. What it will become? Cos x minus sin x. Cos x is equals to minus sin x. So send this cos to the right hand side. It will become like 1 into cos into, right? It will come to the denominator. 1 is equals to minus sin x by cos x. Therefore, we can say here minus n to the left hand side. Can I write tan x is equals to minus 1. Here when you will get 1 in tan pi by 4, you will get 1, right? But here minus you are getting. So which quadrant this is? In first quadrant tan is positive, in second quadrant sine and cosecant positive, but tan is negative. So use pi minus theta. Okay, pi minus theta. So here tan x is equals to tan of pi minus theta. Here theta is when you will get 1 in tan pi by 4. So here tan x is equals to tan of 4 pi minus pi, 3 pi by 4. So tan x is equals to tan y. Now here we need to find the solutions. We need to find solutions which lies from 0 to 2 pi. 0 to 2 pi. So I will write it. We know that tan x is equals to tan y. Then general solution. General solution is equals to x is equals to n pi plus y, where n belongs to z. This is a general solution. This is a formula. Okay. This is a formula. Now here in the place of x, in the place of y, 3 pi by 4 we have. So write a general solution. So x is equals to x only. Y in the place of y just n pi plus y is 3 pi by 4, where n belongs to z. So substitute n is equals to 0 first. You will get x is equals to 0. This is n into pi means 0 into pi, 0 plus 3 pi by 4. You are getting one angle which lies from 0 to pi, 0 to 2 pi, right? Next, substitute n is equals to 1. If I substitute n is equals to 1, I can get in the place of x n 1 pi plus 3 pi by 4. So pi plus 3 pi by 4. 4 pi plus cross multiply and tell me. 4 pi plus 3 pi is 7 pi by 4. This lies from 0 to 2 pi, right? This lies from 0 to 2 pi. And substitute n is equals to 2. So x is equals to 2 pi plus 3 pi by 4. That means this value is exceeding 2 pi. What is asking? X value should lies from 0 to 2 pi. So this value lies exceeding 2 pi because addition of 3 pi by 4 to the 2 pi. That means it is exceeding. So we are not considering this. So therefore, x solutions we have. X solutions, x is equals to how many solutions we have? One is 3 pi by 4. Other is 7 pi by 4. That's all. These are the x solutions which lies from 0 to 2 pi. 0 to 2 pi. Now we don't know. These points are point of maxima, point of minima. We don't know that. Now first we will write what? Differentiation. Call it equation 1. Okay. Just write the equation 1 implies f dash of x is equals to cos x plus sin x. So now again differentiate with respective x. So double differentiation of x is equals to differentiation of cos x minus sin x plus sin x differentiation is cos x. Therefore substitute critical value. Okay, double differentiation of substitute critical value. X is equals to 3 pi by 4. Okay, so substitute minus sin of 3 pi by 4 plus cos of 3 pi by 4. So here 3 pi by 4. 3 pi by 4 can be written as 4 pi minus pi by 4. Okay, 4 pi minus pi is 3 pi, right? So 4 pi by 4 minus pi by 4. 4 cancel, pi minus pi by 4. So 3 pi by 4 can be written as pi minus pi by 4. So I am writing that. Okay, I am writing that. So minus sine of pi minus pi by 4 plus cos of pi minus pi by 4. So here minus sine 180 minus theta, 180 minus theta, 180 minus theta in second quadrant. In second quadrant, sine is positive, cosecant is positive, right? In second quadrant, cosecant sine is positive. Therefore, sine is positive. So sine, let it be sine pi by 4. Next, cos is negative in second quadrant because sine and cosecant positive, remaining all are negative. Therefore, this is minus cos pi by 4. So we can write it as here minus sine pi by 4 is 1 by root 2 minus cos pi by 4 is 1 by root 2. Therefore, we can write it as minus 2 by root 2. Minus 2 by root 2 can be written as minus root 2. Okay, here minus 2 by root 2 can be written as root 2 because 2 can be written as root 2 whole square, right? Root 2 whole square, square root cancel, the same you will get 2. 1 root 2 cancel, you will get root 2, 1. So therefore, f double dash of x at x is equals to 3 pi by 4, value is what? Negative. Okay, negative, which is less than 0. Maxima indicates maxima. And point of x is equals to 3 pi by 4 is a point of maxima. Point of maxima. Now substitute. In double differentiation, substitute 7 pi by 4 now. These are the points, we got critical points. Now we got point of maxima, this, now we need to find this 7 pi by 4. Whether this is a point of maximum, point of minimum, or point of inflection. Okay, now double differentiate, we got double differentiation, right? Where is the double differentiation? Here we have a double differentiation, right? Quality equation to double differentiation. Okay, in double differentiation, substitute the values, substitute x is equals to, where is the critical point? 7 pi by 4, right? 7 pi by 4. Substitute 7 pi by 4 in equation 2. So equation 2 we have here double differentiation. Double differentiation implies at x is equals to 7 pi by 4 is equals to, so I am substituting minus sine 7 pi by 4 minus sine 7 pi by 4 plus cos 7 pi by 4. So 7 pi by 4 can be written as 7 pi can be written as 8 pi minus pi is 7 pi by 4. So 8 pi by 4 minus pi by 4. 4 2s are 8. So 2 pi minus pi by 4 we can write. Okay. The next step I will write the solution. So minus sine 2 pi minus pi by 4 plus cos of 2 pi minus pi by 4. Therefore here 2 pi minus theta means which quadrant? 2 pi minus theta. This is 2 pi minus theta is lies in fourth quadrant. Cos is positive, secant is positive. Remaining all are negative. These two are positive, remaining all are negative. Therefore sine is negative. So sine is negative, negative into negative, positive. Sine pi by 4 plus cos is positive, so cos pi by 4. So this is 1 by root 2. This is 1 by root 2. 1 by root 2 plus 1 by root 2 is root 2. 2 by root 2. Okay. So therefore 2 by root 2 is root 2. Double differentiation at x is equals to 7 pi by 4, which is greater than 0, maxima. It is minima. Positive means minima. Therefore x is equals to 7 pi by 4 is a point of minima. Point of minima. We have to find minimum function, maximum function. Maximum value is equals to, we have to find maximum value, f of 3 pi by 4 is equals to, substitute in the function. Okay, substitute in the, what the function x is equals to, 3 pi by 4 is a 1 value and 7 pi by 4 is a 1 value. Now I am substituting the function. F of 3 pi by 4 value is equals to sin x minus cos x. Sine of 3 pi by 4 minus cos of 3 pi by 4. Already I discussed how can we write here 3 pi by 4, pi minus pi by 4 we can write in the same way, cos of pi minus pi by 4. Okay. So therefore this value is positive sine pi by 4. Next minus, this is plus, it will become cos pi by 4. This is 1 by root 2 plus 1 by root 2. 1 by root 2 plus 1 by root 2, 2 by root 2. Okay. 1 plus 1, 2. 2 by root 2. So 2 can be written as root 2 whole square. 1 root 2, 1 root 2 cancel. Therefore root 2 remains. Therefore root 2 remains. That's all. This is a maximum value. This is maximum value. Okay. Next, minimum value is substitute x is equals to 7 pi by 4. So 7 pi by 4 in the place of sine of angle. Sine of angle we have sine of 7 pi by 4 minus cos of 7 pi by 4. 7 pi by 4 can be written as what? 2 pi minus pi by 4. Okay. Minus cos of 2 pi minus pi by 4. Therefore 2 pi minus pi by 4 is a second, fourth quadrant sine is negative, minus sine pi by 4 minus 2 pi minus pi by 4 is a fourth quadrant cos is positive, therefore cos pi by 4. So minus 1 by root 2 which is minus 2 by root 2. Therefore we can say f of 7 pi by 4 value is minus root 2 is minimum value. That's all. This is a minimum value, this is a maximum value. That's all. And the point of maximum is 3 pi by 4. Maximum value is root 2. Point of minima is 7 pi by 4 and minimum value is minus root 2. That's all.